Unit 7, page 205 to 209, the second fundamental theorem of calculus, functions defined by integrals. Given the functions f of t below, use f of x equals the definite integral from 1 to x of f of t dt to find capital F of x and capital F prime of x in terms of x. So what we're going to do here is we're going to use what we know about the talk to actually find these functions, capital F of x and capital F prime of x. So we're going to start with first writing out what we know. So capital F of x is equal to definite integral from 1 to x of f of t, which is 4t minus t squared dt. So first we need to find the antiderivative of this. So capital F of x is equal to 2t squared minus 1/3 t cubed. We want that from 1 to x. So now using for talk, we'll rewrite this as 2x squared minus 1/3 x cubed minus 2 times 1 squared minus 1/3 times 1 cubed. So f of x equal to 2x squared minus 1/3 x cubed minus 5/3. And f prime of x equal to 4x minus x squared. All right. Problem number 2, now we have capital F of x equal to definite integral from 1 to x of cosine t dt. So first we need to find the antiderivative of cosine, which is sine t, going from 1 to x. So using for talk, we know that's sine x minus sine 1. So f of x is equal to sine x minus 0.841. And f prime of x is equal to cosine x. Okay, we're going to do 2 more problems. But now we're going to say capital F of x is equal to the definite integral from 1 to x squared of f of t dt. So now capital F of x is equal to definite integral from 1 to x squared of t cubed dt. Antiderivative of t cubed is 1/4 t to the 4th. We're going from 1 to x squared. So f of x is equal to, using for talk, 1/4 x squared to the 4th minus 1/4 1 to the 4th. So f of x is equal to 1/4 x to the 8th minus 1/4. And f prime of x equal to 2x to the 7th. For number 4, I'm going to rewrite 6 root t to be 6t to the 1/2. So then capital F of x equals definite integral from 1 to x squared of 6t to the 1/2 dt. Antiderivative of 6t to the 1/2 is equal to 6t to the 3/2 times 2/3 from 1 to x squared. So capital F of x is equal to 4 t to the 3 halves from 1 to x squared. So now using FTOC, we're going to plug in our limits of integration. So we have 4 times x squared to the 3 halves minus 4 times 1 to the 3 halves. So f of x is equal to 4x cubed minus 4, and f prime of x equal to 12 squared. Okay, so this process we used for the next page. We're going to actually apply the second fundamental theorem of calculus, which states that if capital F of x is equal to the definite interval from a to g of x, where g of x is any function, of f of t dt, where a is any constant, then f prime of x is equal to lowercase f of g of x times g prime of x. Okay, we're going to do a few examples to show that that is true. So these 4 functions are the 4 functions that we looked at on page 205. We're just going to rewrite what we got for the derivative for each of those functions. So for this first function, we got that the derivative was equal to 4x minus x squared. So now we're going to apply the second fundamental theorem of calculus to prove that that is true. So the second fundamental theorem of calculus says that we're going to take this g of x and plug it into our lowercase f of x. So f prime of x will be equal to 4x minus x squared, and then the derivative of g of x, which is 1. So f prime of x is equal to 4x minus x squared, which is exactly what we found from page 205. So now let's do another problem. So here we got that our derivative would be cosine x. So if we look at this, take our g of x, plug it into our f of x. So f prime x equal to cosine x times the derivative of g of x, which is 1 in this case. So f prime of x equal just to cosine x, which is what we found on page 205. So if we continue this process, now we're looking at when we have the definite integral from 1 to x squared. So this derivative was equal to 2x to the 7th. So let's double check to make sure. So we plug in x squared. So that should be x squared cubed times the derivative of f of g of x, which is 2x. So f prime of x equal to x to the 6th times 2x, which is equal to 2x to the 7th. And then last but not least, we got that this derivative is equal to 12x squared. And if we check, we get that f prime of x equals 6 square root of x squared times the derivative of x squared, which is 2x. So f prime of x equal to square root of x squared is just x, so 6x times 2x, which is equal to 12x squared, which is what we got. Okay, so we're going to do a couple of these problems on your own. I'm actually just going to do one of them at the top here. I'm going to do g of x, and you're going to be responsible for f of x and h of x using the second fundamental theorem of calculus. So for g of x, we have a definite integral from x squared to -3 of e to the cosine t dt. So in order to use the fundamental theorem of calculus, second one, our definite integral needs to be going from a constant to some function. So I'm going to rewrite this. So g of x equal to, I'm going to flip my limits of integration so that they look the way they should look. And when I flip my limits of integration, I have to change the sign of my definite integral. So here is the function now that I'm going to determine the derivative of. So g prime of x is going to be equal to, I'm going to take my g of x function up here and plug it in. So I have negative e to the cosine x squared times the derivative of x squared, which is 2x. So g prime of x can be equal to negative 2x e to the cosine x squared. Okay, so you're responsible for f of x and g of x in writing their derivatives. Okay, so now we're going to look at the picture to the right, that's graph of g of t. And the function f of x is defined to be f of x equals the definite integral from -4 to 2x of g of t dt. First thing we want to know is the value of f of 0. So f of 0 will be equal to definite integral from -4 to 2 times 0 g of t dt. I will plug in 0 every time we see x in this case because it's f of 0. So this right here is going to be equal to f of 0 equals definite integral from -4 to 0 of g of t dt, which from -4 to 0, we're looking at the area between the curve and the x-axis. So if we look at these two triangles, these triangles cancel each other out because they are the same size and opposite signs. And then we have a quarter circle whose area is 1/4 pi 2 squared, and a rectangle whose area is 2 times 1. So the area here is 2 plus pi. Okay, for number 2, we want the value of f of 2. So we want f of 2 equals definite integral from -4 to times 2, because it's 2x, of gt dt. So f of 2 be equal to definite integral from -4 to 4 g of t dt. Now if we look at this function, this is an even function. Which tells us that if we're looking for this definite integral, that's going to be equal to 2 times the definite integral from -4 to 0 of g of t dt. And we know that this is an even function because it is a mirror image of each other from the left and the right. So we already know what the definite integral from -4 to 0 g of t dt is, it's 2 plus pi, which we learned in part 1. So we're just going to multiply that by 2, and we get 4 plus 2. Okay, now for part 3. Now we want the derivative. So we're going to apply the second fundamental theorem of calculus here. We have f of x equal to definite integral from -4 to 2x gt dt. So we're going to apply the second fundamental theorem of calculus, and we get that f prime of x equal to g of 2x times the derivative of 2x, which is 2. So f prime of x is equal to 2g of 2x. So if we want f prime of 1, that'll be equal to 2g of 2 times 1, which is 2g of 2. So g of 2 we can find on our graph. Just find where the point 2 is, and 2, 1 is our point. So g of 2 is 1. So we have f prime of 1 equals 2 times 1, which is, I want you to attempt number 4. Try to find what f prime of -2 is. And I'm going to do number 5 for you. So number 5, we want g double prime of 2. We know that f prime of x is equal to 2g 2x. So if we want f double prime, we're going to have to use chain rule. So we have f double prime of x equals 2 derivative of the mama with the baby times the derivative of the baby, which is 2. So f double prime of x is equal to 4g prime of 2x. So when we plug in, we want f double prime of 2, which is 4g prime of 2 times 2. F double prime of 2 is equal to 4g prime of 4. Okay, so we want to know g prime of 4. So if we go to 4, oh boy, our graph does not continue on forever. It actually stops at 4, which tells me that our graph is not continuous at 4 because there's no limit from the right side. So f double prime of 2 is undefined because g prime of 4 doesn't exist, since g of t is not continuous at t equals 4. Okay, so now let's look at these last 2 pages. Given to the right is the graph f of t, which consists of 3 line segments and 1 semicircle. Additionally, let the function g of x be defined by g of x equals the definite integral from -1 to x f of t dt. This graph is t. We want to find g of -6 and g of 6. So I actually want you to do problems 1 and 2 on your own. I'll help you set them up. So g of -6 should be equal to definite integral from -1 to 6 f of t dt, which is just find the area between the curve and the x-axis from -6 to 6. And similarly, g of 6 equal to definite integral from -1 to 6 is be careful with number 1 because this definite integral needs to be flipped. Those limits of integration need to be flipped. So g of -6 needs to be equal to, because we need to have the smaller number on the bottom, so -6 to -1. And when we flip limits of integration, we need to change our sign to negative f of t. Okay, so work on those 2 problems and we will continue on. Okay, so we want to find g prime of 6 and g prime of 2. So first let's find what g prime of x is. So we know that g of x equal to definite integral from -1 to x f of t dt. So using our second fundamental theorem of calculus, we'll plug in that function. So we have g prime of x equal to f of x times the derivative of x, which is 1. So g prime of x equals f of x. So now that we know that, we know g prime of 6 will be equal to f of 6. And if we look at our graph, f of 6 is equal to 2. Okay, it's f of 6. It's just a point, so it's 6 comma 2. So f of 6 is equal to 2. Find g prime of -2 on your own. Now we're going to look for the second derivative. So we know that g prime of x is equal to f of x. So g double prime of x will be equal to f prime of x. So g double prime of 2 equals f prime of 2. And if we look at 2, point 2 is on a cusp. Therefore, it does not have a derivative. So f prime of 2 is undefined because f of t has a cusp at t equals 2. And g double prime of -4, however, might exist. So f prime of 4. So if we look at 4, sorry, -4. -4 is on a line, which is great. So all we need to know is the slope of that line. So rise over run, we have -6/3. So g double prime of -4 is equal to -2 because the slope of f of t at t equals -4, -2. Okay, so last page, last problem. The continuous function f is defined on the interval from -4 to 3. The graph consists of 2 quarter circles and 1 line segment as shown in the figure above. Let g of x equal 1/2 x squared plus the definite integral from 0 to x of f of t dt. We want to find the value of g of 3 and g of -4. So I'm going to set these 2 up for you so that you can find them on your own. So g of 3 will be equal to 1/2 3 squared plus definite integral from 0 to 3 f of t dt. So you're going to do this out, use the graph to find that value of the definite integral. And g of -4 equal to 1/2 -4 squared plus definite integral from 0 to -4 f of t dt. our definite integral needs to be flipped. So we have 1/2 -4 squared. We're going to flip our limits of integration from -4 to 0 of f of t dt. And when we flip our limits of integration, we change our sign. So you're going to use that information in the graph to help you determine that value as well. Down at the bottom, we want to find the value of g prime of 3. So since we know that g of x equal to 1/2 x squared plus definite integral from 0 to x of f of t dt, we can find g prime of x. That'll be equal to x plus f of x. And the derivative of x is 1, so that's there. So g prime of 3 is equal to 3 plus f of 3. And if you look at your graph, f of 3 is equal to -3, so g prime of 3 equals 3 plus -3, which equals 0. And since we know that g prime of x is equal to x plus f of x, we can find g double prime of x by taking the derivative of that, so we get 1 plus prime of x. So g double prime of 2 equals 1 plus f prime of 2, which is equal to 1 plus, and if we look at this, 2 is here, so we can find that by taking the slope of this line, which is -6/3. Which is equal to 1 minus 2, which is -1. Okay, and that concludes our video for pages 205 to 209 of Unit 7.